couple of questions have come up as to what is terminal velocity, so let's take a look at it. Easy example is, we'll just imagine a skydiver here. Alright, so there's a little skydiver, they jump out of the airplane, and when somebody first jumps out of the airplane, the only force acting on them would be the force of gravity. Alright, so when they first jump out, they're going to have the force of gravity on them, so what this does is it gives them a net force equal to the force of gravity, just in the downward direction. And anytime that there is a net force, you know that that object that has mass, which if you're a skydiver you have mass, or any other object for that matter, is going to accelerate. But now, if you accelerate, what this means is you're going to be changing your velocity. And since the net force is downward, you're going to be increasing your speed in the downward direction. If you've ever stuck your hand outside the car window, you know that as you increase speed and you run your hand through the air, what starts to happen is you start to feel the force of air resistance. So in this case, this would act back on them. And at this point, we'd have a little bit of air resistance. Now, all this does over here is to our force of friction, our net force, is if the net force used to be the same size as the force of gravity, by adding in the air resistance, all that's done is just shaved off a little bit of it. But we still have a net force, so we still have an acceleration. And if you have an acceleration, like we said before, you're going to go a little bit faster. And if you go a little bit faster, you're going to get more air resistance, and all this is going to do then is make the force of friction a little bit, or I don't know why I keep saying friction, but it's going to make the net force get a little bit smaller. Net force is smaller but still there. You're going to get faster, and if given enough time, eventually the force of air resistance acting on this object is going to completely cancel out the net force. And as soon as that happens, your net force is going to go to 0. And I think I misspoke. I said that the force of friction would cancel out the net force. That's incorrect. The force of friction is going to cancel out the force of gravity, giving us a net force of 0. Now, the only way this happens is if you have a net force of 0, one of two things has to happen. You either have to have 0 mass, or your acceleration would have to be 0. But you have mass, so that's not going away. So all that happens is your acceleration goes to 0. If an object has 0 acceleration, what this means is its change in velocity is then 0. And so therefore, if you're not changing your velocity, what you're doing is you are staying at the same speed. All right, so this is the speed you're at. Now remember, you've been falling for a while, so you've been getting faster and faster and faster, but you can't get any faster. So you're usually going pretty fast. But since this is the end speed or the end velocity you can get to, we use the word to represent end, which is terminal. And then we say velocity. Okay, and so since the object can't get any faster, this is the final speed it can move at, we say that the object has reached its terminal velocity. All that really means is the object can't get any faster. The change in velocity has stopped. It's because the acceleration is 0, and the acceleration is 0 because the sum of the forces is now 0. This happens because the upward force caused by air resistance is the same size as the force of gravity. Now there's an interesting thing that happens here with this. This is why people tend to think that heavy objects fall faster than light objects. So just imagine that you had a beach ball, all right, and you had a bowling ball. All right, so here's our two beach balls. Well, the beach ball is very, very light, so it does not have a big force of gravity acting on it. The bowling ball, being very dense, it's very heavy, it's got a large force of gravity. Now, these two objects are roughly the same size, so they're going to have roughly the same amount of air resistance, but in order for the bowling ball to experience the same upward force to cancel out its force of gravity, it would have to be moving much, 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 much faster in order for its force of air resistance to cancel it out. The beach ball, on the other hand, does not have to fall for very long before it maxes out at its top speed and gets itself into its terminal velocity. So as a result, the bowling ball's terminal velocity will be much faster than the beach ball's, not because heavier things fall faster than light things, but simply because it has to be moving faster until it can cancel out its force of gravity with the force of air resistance. Now all these pictures, you'll notice here that the net force is equal to 0. We use a special term to describe that. Anytime the object has a net force equal to 0, which happens in terminal velocity, we say that the object has reached what we call equilibrium. All right, so that's a quick little review of what is terminal velocity. If you have any questions, talk to me in class.